Behind me is a cathode, and behind you would be the anode mixers. They are more or less they have identical machines. It's just that the cathodes here, the anodes here, we like to keep the materials separate. So we can go down slowly down in this direction. The mixers we have are a prototype scale, so they are something like 50, 60 liters or so. We have a couple of these on both sides so that we can go through a few different mixing batches. The primary objective of the prototype line being to test different materials for processability, performance, and various other things that we like to test. So we can go a little bit further in this direction, I guess. We've got a small display for visitors, but I think you'll be quite well aware what most of this is. So we've got a sample of different materials that we're using.
So here we can test new materials and make cells up to a pre-A sample.
Come in with me. Come in with me. Come on with me. This machine will be responsible for the die cutting of the electrode rolls. And it's basically just a stamp that cuts out the electrodes to shape so that we can stack them directly. This is a prototype line, so we stamp them out directly in a mass production environment that you may have seen before. A combination of slitting and stamping procedures might be used, or laser cutting, or any combination. We do this for all of our cells, so this is a complete test to sort out if there are any issues. So far we've had very few issues. If the welding wasn't good, or if there was a disconnection somewhere because of some flaw in some dramatic flaw, then we can quickly sort it out. But so far we've had no such issues, so it's more of a let's just make sure kind of thing because it's a quick test. So where we are today right now is the materials lab. The main activity we do here is to do an initial screen of the different materials that we'd like to test and experiment on. Different types of cathode and anode materials, different types of separators, and so on. So we've recently passed a milestone of 20,000 cycles with our current cell design that we have already commercialized. This is 20,000 cycles at 5C, up and down 5C, 5C. And we have shown that it retains well above 70% stellar health. So this is an important milestone as well, because previously we had designed and really kind of aimed for a milestone of 10,000 cycles, which we easily passed. And now our cells are showing pretty good performance at even 20,000 cycles. So this is not a projection or simulation or calculation. This is 5C up and down for the past year and 2 months or so. So we've really been continuously testing non-stop, and to show that the results are basically the real data. And I think we'll be able to release some results as well. Thank you.